So now you've mastered the product rule and basically every rule before that. And now, oh my god, I'm so confident. So you start doing more differential problems, and initially everything goes well until you encounter this question, which is f of x is equal to sine of x divided by e to the x power. Now, from the previous experience in implementing the product rule, you may be tempted to do something like this, okay? So you may be tempted to transform f of x to sine of x times e to the negative x powered. Well, you can do this. After some differentiating, you'll realize that for this to work, you need to not only use the product rule, but also the chain rule, which we did not really cover. So this method is not really the most straightforward one. Therefore, today we are going to introduce yet another brand new concept called the quotient rule. This is how to spell quotient, by the way, called the quotient rule, which is really just a differentiating rule that deals with all those f of x divided by g of x, basically all those fractions. So the quotient rule states that if we have an f of x and a g of x, then f of x divided by g of x, which we're finding the derivative, is equal to f prime of x times g of x minus g prime of x times f of x divided by g of x squared. Okay, so basically this is the rule we're going to use. And again, we're obviously going to prove this rule. It's always better to know how to prove it rather than just memorizing it. So let's start our proof in this half of our board. So proof. Again, we always start with the definition of derivatives, and in today's proof, we're also going to do exactly that. So by the definition of derivatives, we have that the derivative of f of x divided by g of x is equal to limit as h approaches 0 of f of x plus h divided by g of x plus h minus f of x divided by g of x over h. Now, simplifying this limit, we get limit as h approaches 0. So basically, we have f of x plus h over h times g of x plus h, and then minus f of x over h times g of x. Okay. Now, further simplifying this limit, we get f of x plus h times g of x minus g of x plus h times f of x. And we have on the denominator h times g of x plus h times g of x. Okay, cool. So now what we're going to do is pretty similar from our proof in the last video when we proved the product rule. So what we're going to do is we are going to plus g of x times f of x, then minus g of x times f of x in the numerator. And in doing so, this will enable us our ability to basically factorize the numerator to get what we want. So let's rewrite the limit again. So what we are going to do is that we are plussing f of x times g of x, and we are going to minus f of x. I'm running out of space. Please bear with me. Times g of x, and then divided by h times g of x plus h times g of x. Great. Now we can start factorizing. Exactly the same like yesterday. So factorizing, we get, so g of x bracket, we have f of x plus h, and we have minus f of x bracket, and then minus f of x, okay, bracket. Inside the bracket we have g of x plus h minus g of x, okay, divided by h times g of x plus h times g of x, okay. Now you'll realize a huge similarity to the previous proof where we proved the product rule, because again, you'll see something like this, okay, which I believe you are super familiar by now, is the definition of derivatives, which is stating the derivative of f of x. And again, here you see this expression, which pairing with this h is again the derivative of g of x. So just to make this a little bit clearer, so we can break this down. Basically, we can break this fraction down into two fractions. So the first one is g of x on the outside and brackets f of x plus h minus f of x brackets. Then we have h times g of x plus h times g of x minus f of x brackets g of x plus h minus g of x brackets. And we have the same thing on the denominator, which is h times g of x plus h times g of x. Now, I've made this really clear because this expression right here is the derivative of f of x, and this expression right here is the derivative of g of x. So let's rewrite this into limit as h approaches 0 of g of x times f prime of x minus f of x times g prime of x over. Now, we've already used up the h in the definition of derivatives. Therefore, what we're left with on the denominator is g of x plus h times g of x. And now we know that h is approaching 0, so we can ignore the h because h is equal to 0. So therefore, what we have on the denominator is g of x squared. So finally, we get g of x times f prime of x minus f of x. You know what? I'm not going to write it right here because I think I'm running out of space. So therefore, we get our answer, f prime of x times g of x minus g prime of x times f of x divided by g of x squared. And this is exactly the same as stated in our quotient rule. Therefore, we have proven our quotient rule. And now, just getting back to the original function, so let's solve this f of x now. Now, this makes it really clear. Basically, this is, so basically, uh, f prime of x is going to be equal to the derivative of sine of x is cosine of x. So cosine of x times e of x minus the derivative of e of x is e of x. So minus e of to the x powered times sine of x. We don't change that. Finally, dividing e to the 2x powered, which is e to the x powered times cosine x minus sine x over e to the 2x powered. Now I can simplify more because we have e to the x powered here, and I have e to the 2x powered here. But since I'm running out of space, I'm just gonna leave it like that. So this is going to be the end of our video. So I hope you enjoyed today's video, and I'll see you in the next session.